One area of Integrated 3 is going to be dealing with statistics and working with data. This is a very important part of the course, and it's a very important part of mathematics in general. Those of you who plan on taking the SAT, which should be most of you, it's a heavy focus now on the SAT, and it's also probably the most common form of mathematics that gets used in real life. So first form we're going to look at is just how a method of displaying data, so we can describe it and be able to recognize things. A box plot is probably the easiest one to do. It's the easiest way to easily display data so you can see what's going on. It doesn't quite tell you as much information as something like a histogram or some other ways of laying it out, but it is probably one of the most convenient. So we're going to build a box plot. Now, in order to build a box plot, the first thing I'm going to need to do is to put the data in order. So I'm looking at the data. I'm typically going to go from lowest to highest. So I see 7, and as I write it out, I like to kind of cross it off. My next lowest number, if I go through my list, is 13. Then I have a 14. I have a 15. I have another 15. Then I would go 17, 19, 19, 20, 21, 22, and then 28. So I got my data already organized to make it go a little bit easier so we can actually see it, because it's hard for me to write on the tablet. There is a total, if we added up all the numbers here, there are 13 data points. The first part of building a box plot is finding the median. The median is the middle value. If you have an odd number of data points, your median is going to be the one that's dead center. Now, if you're not sure how to find it, here's a trick. I have n equals 13. That n represents how many data points you have. N plus 1 is 14, so I add 1 to it, and if I take that divided by 2, my median is at the 7th value. So I can go 1, 2, 3, 4, 5, 6, 7. Now, in this case, it's pretty easy to figure out where it is. If you add 1, divide by 2, it works. If there's an even number of data points, you're going to get a decimal. You might get 17.5. Then you go halfway between the 17th and 18th value. So first point is 18. That is my median. And now what I'm going to do is find the quartiles. The quartiles is taking the data, it's been broken in half. I got my lower half and my upper half. The first quartile is going to be in the lower half. The median represents the second quartile. The third quartile is the median of the upper half. When I find my quartiles, I do not include the median value. So I just go right in between. I got 6 values, so I got to go in between the third and the fourth value. So I just take and find the middle of 14 and 15. In that case, it's 14.5. Just add the two together, divide by 2. Third quartile will happen between 20 and 21. So that is 20.5. The other parts of our box plot they're going to come from are our minimum value, which is 7, and our max, which is 28. Helps to build a little bit of scale so you could draw your box plot. You just don't want to kind of draw it arbitrarily without spreading it out. With some form of scale helps to do that. And you may have to create it on your own, or you may have to label it. So I've got these data points right here. I can see, if I went by ones, I wouldn't have enough room to be able to go by it. Could try to go by something weird, but nice numbers, either even numbers or multiples of 5. It's a good idea to kind of get going. So I'm just going to go 0, 5, 10, all the way up to 35. Even though I'm not going to go all the way out with the numbers. But it's good in the sense that if you have to build things and then show like comparison of 2 data points, you can like stack them on top of each other so you can compare. First part is building the box. So I'm going to go from Q1 to Q3. So my box is going to go from 14.5 up to 20.5. And if you want to be real clear about your diagram, you can always add in those numbers. The median is at 18, so I'll draw a line at 18. The other parts now are going to be what are called the whiskers of the box plot. So also sometimes hear these called box and whisker plots. So I'm going to go and down to my minimum value, which is 7. And on the other end, I'll go up to my maximum value, which was 28. Now I'm going to build a 5-point summary. And I know I have a typo because I just realized it. My 5-point summary, this should have been 28, not 23. So 5-point summary is listing them in order, the minimum, Q1, median, Q3, and your max, which was 28. The other component from a box plot that you need to be aware of is what's called the interquartile range. The interquartile range is the width of the box. So it's abbreviated as IQR, and to find it I do 20.5 minus 14.5. So the width of the box is 6. Now, what I'm going to do with this is you can also start talking about all kinds of things about this distribution. This distribution is pretty symmetric. If I look at it, my 2 whiskers are about the same size. My median is roughly in the middle. This would be represented as a symmetric distribution. It's roughly symmetric. It's not perfect necessarily because it's maybe not be exactly in the middle. But when we go over and look at it, you can get like I think the exact middle might be 17. But it's roughly symmetric, and that's going to be one of the things. And the other ones you'll be looking at are things like distributions that are skewed. If it's skewed, one of these tails will extend out a lot further than the other ones. And you might see the median, pulled, really close to like Q1 or something. And wherever the longer tail is, that's the direction of the skew. And that will be another topic we will be looking at.